Welcome to The Explainer. Today, we're diving deep into something that affects pretty much all of us, every single day: software engineering.
So let's just jump right in with a question that I know we've all asked, probably out loud in a moment of sheer frustration. Why do our apps crash? Why are some websites just impossible to figure out? What's the deal? Why is building good software so hard?
And look, that's not just you feeling frustrated. This is a real, well-documented problem in the tech world. For decades, a huge number of software projects have just gone off the rails. They run over budget, they blow past their deadlines, and at the end of the day, the quality just isn't there. Yeah, this whole problem actually has a name. It's called the software crisis. And what it really boils down to is a giant mismatch. You've got this explosive demand for bigger, more complex software. I mean, think about the systems that run our banks or our airlines. And then on the other side, you have the actual methods and tools we're using to build them, which are struggling like mad to keep up. That clash, that's the crisis.
The brilliant computer scientist Edsger Dijkstra really nailed it when he said this. As our computers got more and more powerful, truly gigantic, the problems we had to solve with programming became, well, equally gigantic.
So you have this chaos, right? How did the industry fight back? Well, it had to grow up. The solution was to bring some order to the madness, to add discipline and structure. Basically to start treating software development less like a freewheeling art form and more like a real, formal engineering discipline. And that brings us to the big idea here: software engineering. So what is it? It's really just the systematic application of engineering principles, the same kind of thinking that builds bridges and skyscrapers, to the entire process of making software, from the initial idea all the way to launching it and keeping it running. And the goal? It's pretty simple, really. Make good stuff on time without breaking the bank. Okay, but to engineer it right, we got to be clear on what we even mean by software. Because it's not just the code, not just the app on your phone. In the world of engineering, real software is the program plus all the documentation that comes with it. We're talking everything from the initial plans to the user manuals.
Exactly. You have to think of it as the whole package. The program itself is kind of like the engine of a car. It's the most important part, for sure, but it's not the whole car. It only becomes something you can actually use, something robust and reliable, when it has the chassis, the wheels, the user manual, all that supporting stuff.
So that begs the question, right? How is building software different from, say, building a physical bridge? They're both engineering, but the products themselves are just fundamentally different, even if the goals of quality and reliability are the same.
And here's a huge difference. You don't manufacture software on an assembly line like a car. You develop or engineer it one project at a time. And think about this. A bridge or a car wears out over time. It rusts, it breaks down. Software, it doesn't do that. The code itself doesn't degrade no matter how many times you run it. But, and this is a big but, it can absolutely become outdated or obsolete.
So to handle this unique, intangible thing we call software, engineers needed a roadmap. They came up with something called the Software Development Lifecycle, or SDLC for short. Think of it as the master blueprint for taking an idea and turning it into a real working product. In this life cycle, this blueprint, it usually breaks down into 4 core phases. I can pretty much guarantee that every single high-quality app you love has gone through these steps in some way. First, requirements. Then, design. After that, testing. And finally, maintenance.
It all kicks off with requirements. This is where you figure out exactly what the software is supposed to do. And let me tell you, this sounds simple, but it's often the hardest part. It can be a total minefield of misunderstandings and vague ideas. Getting this stage right is absolutely crucial. If you mess this up, the whole project can be doomed from the start. Okay, so once you know what you're building, the next logical step is how you're going to build it. That's the design phase. And the house blueprint analogy is perfect here. You wouldn't just start building a house without a plan, right? Same thing with software. You map out the whole structure, what all the different pieces are, and exactly how they're going to connect and work together. All right, blueprints are done, building starts, and then comes testing. And this isn't just a quick, does it turn on, check. No way. It's a whole process with lots of layers. You have engineers testing the tiny individual pieces, then they test how those pieces work together, and then, the big one, they test if the whole thing actually does what the user wants it to do.
And even after all that, when the software is launched, the job is far from over. That's where maintenance comes in. This is so important because good software is really a living thing. It's never truly done.
It has to keep evolving with bug fixes, security updates, and cool new features to actually stay useful and relevant.
So, we've talked about this whole crisis and this big, structured process. But let's bring it back to you. Why should you care? What's the point of all this? And how does it actually affect you when you're just trying to use an app on your phone?
Well, the end goal is simple: high-quality software. And that really breaks down into 4 key things. First, correctness. Does it actually do what it's supposed to do? Second, usability. Is it easy and intuitive to use, or is it a confusing mess? Third, reliability. Can you count on it not to crash all the time? And finally, efficiency. Does it run fast and smooth without hogging all your phone's battery?
So, I'll leave you with this final thought. The next time you use an app, and it's just seamless. It does exactly what you want. It's fast, it's beautiful, it just works. Take a second to think about the incredible amount of invisible engineering that went into that. All the planning, the design, the endless rounds of testing, all of it just to create that simple, perfect experience for you.